Hi, good evening and happy Sunday. Thanks for all who have joined in. And today we are going to have a session on Introduction to Kubernetes, and this is hosted by WIMLDS. WIMLDS stands for Women in Machine Learning and Data Science. It has a wonderful mission to support and promote women and gender minorities who are practicing, studying, or are interested in fields of machine learning and data science. Opportunities are created for members to engage in technical and professional conversations in a positive, supporting environment by hosting the talks by women and gender minority groups who are working in data science and machine learning. So that is so it's very helpful if we are part of this community to get drumbeats of what is happening and where we stand and to learn a lot. And the events, what they organize are technical workshops, networking events, and hackathons. And irrespective of all these, the community is completely inclusive and it supports irrespective of gender identity. And the community partners for WIMLDS are Co-Learning Launch and Applied Singularity. So the websites are listed here: colearninglaunch.com and appliedsingularity.com. The co-learning web singularity.com is they have a YouTube channel as well, so we can subscribe and see what are the videos that are being posted, which will help us to learn well. And Applied Singularity, they have their app, which has latest updates on data science. So without further ado, let's start off with the session of today. That is Introduction to Kubernetes. And I am Lakshmi Gayatri. I work as a staff engineer with VMware software. I have got about 16 plus years of experience, and I had been with VMware for about 14 years. So my current role is about working on Kubernetes, building cloud native applications. So let's learn about Kubernetes now. So here is the brief agenda. This session is for 1 hour, and we also have demos. We have two demos. And so briefly, the agenda outline is like this. We'll be talking about container first, which is a building block, and then move on to the container orchestration, which we'll be talking about Kubernetes. And for Kubernetes, we'll be talking about the architecture. We'll understand the key components, see how the lifecycle management of applications is easy with Kubernetes, and then move on to the demos, which will apply what we have learned to what we are going to see. Now, coming to the container, the moment you hear this word container, what comes to your mind? It's a box with packaged with something. So that is what comes to the mind. So this is what a container is about. We'll just briefly touch base upon the container topics as these form the basic building block to understand Kubernetes. So for container is nothing but it has the code and all the dependencies. So the application can run quickly and reliably. So if you see the image here, you can see certain boxes, some containers. So the applications and the bare minimal code which is required to run these applications is all packaged into these boxes. And these boxes are independent of each other. So the application, so crashing of one application is not going to cause any damage to the application, though they are still sitting in the same space. So the recently after COVID-19 situation, this was one of the mostly circulated image on the Docker community. So wherein Docker says that the isolation of apps inside containers is a way to design it. And different applications, even if they crash or anything, they don't have any effect on the others. So we should be like a Docker container at the moment. We should self-isolate ourselves, be safe, and then fight Corona. How are these Docker containers built? So as we know that these are just applications, right? So these applications are built by a file system method called layered file system. So this layered file system is what we are going to see it in the next slide, like how to write this particular Docker file, which is nothing but a declarative spec we write saying that this is how my image has to look like. And layered file system, in the sense, what I mean is you can keep on adding whatever applications you want in the stack. Just like in this image, you see applications are stacked one over the other, right? At the first one has like five containers stacked on top of each other. So which means there can be like n number of applications. You can stack them all together. This comes very handy when you are writing applications which has some UI front end, some middleware application, and a database. You can have each container represent different application and still make them look like a single application. So this is a sample for a Docker file. We can write it in any using any text formatter or something. It just the file name would be called as Docker file, and these are the four basic things which your Docker file should have. The first thing is we'll have to define from which operating system or from which image we are building. So think of it like this. Say if at all I want to run a nginx application, one example what we are going to see. In that nginx application, it's a web application. If we will have to have such web application, typically what we do, we need a machine that is running, say, Linux or Windows. Some operating system is required. On top of that application, on top of that operating system, we are going to install the application. And then using the browser, we access to, let's say, port 80 on which nginx runs to access what the web application is hosting on. All this requires steps. And when we come to containers, there is in the previous slide, as we have seen, it has the application, the basic code which is required also packaged with it. So we are not going to install operating system every time we want to have a container exist on it. So what this image is built of, it is built of a thin layer of operating system. So here the operating system what we are using is Ubuntu 18.04. So we are creating a layer from Ubuntu 18.04. It can be any version that you are interested in. So based on that, we just need to mention from which operating system colon the version. If version is not specified, by default, the latest version which is available on the Docker Hub is picked. And the moment we say from, we also say like copy dot space slash app. So what it does, just like a copy command, it's going to add files from your Docker client's current directly into the app folder. And the third line here says run make app. So make command, we know, right? It is used for building applications. So by doing this, we are going to build applications using make. This is an example Docker file. So we can have Dockerfile run up to like more than like tens of lines or more than that. And the last line is the command. So this command is nothing but the command which you want to run within the container. It can be something like maybe like send SMS or something, or it can be something like a task or a job which has to run. So you say the command. Uh, Here we are talking about a Python application. So you'll have to prefix it with Python and the path to the py file. So what it does is the moment the image is built using Ubuntu with version 18.04, we are copying certain files into the Docker client's directory, building the application using make, and once the application is built, we are also executing it using cmd, this command. This example of this, the reason why dockers are becoming more prominent is because of the ideology that once the job is done, they actually exit. They do not consume any of your infrastructure, or they don't consume your memory or cpu, nothing like that. So the best example what I can give you is when the salary gets credited, we receive an sms to our phone. So for this, do you think that the bank is going to invest in infrastructure throughout the month just to be able to send SMS for a salary credit? No, that is going to be a waste of resources. So what typically use case it can use here is they just need to know like what is the amount and the mobile number that is mapped to the account number which is held with the bank, and then create an SMS and send it. So this creating SMS itself can be the command which is run inside the container. The moment the SMS is gone, there is no need for the container to be still around. So once the job is done, the container will self kill itself. So the job is done. So it just exits the process. And using this Docker file is what we do build using Docker build. And then image is when we do Docker build, it creates a Docker image. The runtime instance of an image is nothing but a Docker container. So this is one thing which we'll have to remember. We will move on to Kubernetes in a minute, but before that, we need to understand how containers are built. So we have a Docker file, which is just a file which is written syntactically in English, and then we just run Docker build on it to create an image. Using that image, we actually create a container which is working. So there you can have Docker installed on your Linux, any Linux machines, or Windows also there is a support, though I have not worked extensively on Windows. So Windows latest operating system do support Windows Docker. Now, just a simple example. Now what we have done is we did Docker run. Name of the application is nginx, and then we have just did some port binding. The port 8080 of the port on the host is mapped to the container port. The one on the right side is the port on the container, and this is the name of the app which we had. This is the display name which we give. So when this is run, when from your laptop, this is my directory, home directory. I'm executing Docker run. So how do we get Docker run? We'll have to download the Docker CLI. Once we have Docker CLI, then we will be able to run the Docker commands like this. So if the image is not present locally, what Docker does is it will download the image from Docker Hub, and then it will pull it onto the local file system. So don't worry, you will be able to do run, but if it will first check if the image is there. If it is not there, then automatically the image will be pulled. Otherwise, you can also do Docker pull first and then do Docker run. So the image gets created, you get a long string, so which means that the Docker run actually had instantiated, and now you have a container ready. So now this is the IP address of my machine, and then on port 8080 I'm having a nginx instance being run, and this is very quick. Say for example, if I'll have to do it on my laptop, I'll have to download the suitable version of nginx depending on whether my laptop is Windows or it is Linux. And I also need to worry about the latest one. Am I using the latest recommended one, or am I on a release which is 1 year old? But with Docker, the ease of moving across releases and also updates is very quick. So here we see, just by running this command, we are able to launch Docker. Now let us see what are the challenges we have with having containers which are run on laptop. So most of us will be having our own home systems where we'll be installing Docker. So that will be usually on your laptop with less number of containers. So it is easy for us when we are developing applications. When we are developing certain images, it's easy for us to work on laptop or something. But when we will have to push it onto the production, then lot of challenges do come into picture. The challenges which are listed on the right hand bubble here. So it's like you will have to take care about networking, you'll have to take care about monitoring of the systems, accounting, the storage which is being used, how secure are your applications are. Security is one of the key aspect which cannot be ignored during the building of these applications, and how portable it is. As you know, Docker containers are highly portable. Like you just build once and then they can be moved to any platform. Like once we push an image, right? The image can be deployed on-prem, I mean on your data center, and you can also push it to the cloud. The same image, you don't have to change anything on the code. You don't have to recompile. As is, it can be ported. And backups and restores, disaster recovery, all these issues do come in, and it's very hard in order to maintain these without any orchestration is nothing but automation. So it looks like this. See how chaotic the room is. So if there is no orchestration, so this is how it's going to look like. So there is no orchestration, it's very hard to manage. You don't have insights on what is failing, how is the failover mechanism happening. The lens with which we see as an admin or the developer is going to be very critical. So on the right hand side, you see it's all well placed. The difference between these two pictures is the presence of an orchestrator. So once you have an orchestrated, it is easy to manage your containers. And this is where Kubernetes comes into picture. So when you will have to manage your containers in production, the go-to solution is Kubernetes. Every cloud has its own Kubernetes engine, which can be leveraged using a pay-as-you-go model, or some of them give free credits also. So it's easy for you to just jump onto one of them using your free credits. You can still go ahead and learn. And we also have Cube Academy, which can be looked at to learn more about what containers are, what Kubernetes are about. So let's take a short quiz here. Just one question, which has two answers. So just try it. The question goes like this: which of the two following use cases are better suited for containers? So now we know where containers do work. We know how to build them. So let us see where to apply them. I'm going to give you a minute to go through these four options. Just note down the answers. And then in the next slide, I'm going to show what the answers are. But just think through, and then let your thoughts flow on what will be the best suited for containers, the use cases here. Okay, so here you go. If you had selected A and C, or the first and third options, then you're right. The reason why it is right is because the first one says the software provider needs a distributed software that can be reused by other companies in a fast and error-free way. So that's what we discussed. So once we build the container, it can be used at on-prem or cloud. And it doesn't matter if you want to give it to some other company or you still use it within your company between different BUs. And the second option says a company is deploying applications on a physical host and would like to improvise its performance by using containers. So there is a catch here. Containers are running as a hosted element, so they still need some basic operating system at the bottom. So we cannot use them for improving performance, and that too when the application needs to be installed on a physical host, we cannot guarantee the environment and the make, the model, the APIs that the hardware exposes. So that's going to be very difficult. So portability aspect is beaten down here. So that's when we have not selected option 2. Third one is a data center is looking for alternatives to shared hosting of database application to minimize the amount of hardware processing needed. So this makes sense. Why? Because we are sharing the hosted sharing of resources is what is happening. So we pool it in within a data center, and then you are using it to minimize the hardware processing needed. Because you host the application in container, it's going to be more effective use of the hardware. The fourth option says a financial company is implementing a CPU intensive risk analysis tool. Again, CPU intensive risk analysis tool will need a machine which has high end CPU. So as long as you have some infrastructure needs like this for the application, it's not right to go with the containers. Now, let's move on to the Kubernetes aspect. So before we start, some of you might have seen this Dilbert cartoon, wherein the manager comes and then he will start a dialogue with his employee saying that I need to know why moving our app to cloud didn't automatically solve our problems. The employee says, you wouldn't let me re-architect it to be a cloud native. The manager says, why don't you just put it in containers? Suggesting that putting in containers is going to ease out the pain of management. But then putting in containers is not just going to help. The employee says you can't just solve a problem by saying techie things. The manager immediately comes up with the second one saying that, okay, put it in Kubernetes. Because Kubernetes is known for container orchestration. It is a market lead for doing this. And we also have Docker Swarm and Mesos, but Kubernetes is catching up great momentum because of the community that is supporting drive this cloud native initiative. Now, this is typically a Kubernetes architecture. This is a busy slide, but I'll make it very simple for you to understand. So in Kubernetes, now this is the user who connects to the API server using kubectl. So like you have Docker to connect to containers, we have kubectl for Kubernetes CLI. It is Kubernetes CLI. And we have something called etcd. This picture representation you know very well, it's like a database. So etcd is a very high efficient key value store, and it stores all the data with respect to the clusters, the configuration, the states, the entity, the objects. All these data is stored on etcd. And along with this api server, we have a controller, manager, and scheduler. So scheduler, what it does is, I'll just move over slide to tell you what a scheduler does. So scheduler's job is to make sure the incoming applications, when they're coming in, it has to make sure the applications are placed on the right homes. So when I say right home, it is nothing but the node. So here, when the pods you see run inside nodes. So instead of calling it as a master and worker, you can call it like a master and node. So master is the one which is like the like a manager who takes care of things, of managing who does what. The pods are the ones where the application is actually running. Pod is nothing but a single or a group of containers put together is called a pod. I have a pictorial representation so you won't forget what a pod is. So pod is the least, the mostly used, the least deployment unit in Kubernetes. It's the smallest one. So these pods will be running on nodes. We don't have pods represented here. So the master will be having a controller and a scheduler, and it has an API server which is connected using kubectl. Kubectl, you can install it on your laptop or on any Linux machine. It has versions, and then based on that you connect to the API server. So the scheduler is the one that ensures that the pods which are incoming are placed on the nodes correctly. So it can decide to put all the, here there are 6 pods, right? 2 per node. It can decide to put all the pods here, or it can decide to put all the pods here. So that is declaratively defined by the user. As a quick recall, as the name says, kube scheduler is the one that schedules, and the incoming pods are actually transported and put onto the respective nodes. So Kubernetes take the decision by keeping in mind the constraints with which the deployment is coming in, whether which node will be the best suited for the pod application. And then this is the controller. Controller is the most important thing because that is what is always constantly monitoring the Kubernetes cluster. See the word, I'm using the word cluster because we have a combination of master nodes and the worker nodes come together and form a cluster. So controller, what it does is it's always watching the Kubernetes cluster, and then in case there is a deviation happening on the Kubernetes cluster, it ensures by making small steps to bring it back to the original state. So what it means is, so for example, we say that at any given point of time, we need to have 5 replicas of an application because we always expect 5 users to log in by 9 a.m. in the morning. So Kubernetes, it ensures that always 5 pods are available for the application. So in case something happens and your fifth pod goes down, even before we jump into action or we get notified, Kubernetes, what it does is when it detects that there is a pod failure, it will automatically provision a new pod in its place and join the core. So with this, what happens is at any given point of time, it always maintains what the user declares as, also known as declarative state. So one simple example is, if I'll have to book a cab from here to say Mysore Palace. So I don't have to tell the Uber driver that take right here, take left here, stop there, stop here, you take this road, it's a shortcut. But what happens is when we say that declaratively that I'll have to go to that destination, which is my destination, which I'll have to go, the steps are automatically taken incrementally in order to get you close to the destination and finally put you in the destination. And if I choose to still say that my destination is that and I ask the cab to take a detour, still it will come back to the same place, right? So you end up still in the Mysore Palace only. So that is what controller does. The controller is always watching the cluster and make sure that cluster is in the state that the user wants it to be. Now let us come to the components in Kubernetes. Now we saw containers, we saw how to build the Docker images, we saw how to run them, and then we also saw the need of why we need an orchestrator like Kubernetes. Then the next step, we saw the architecture of Kubernetes, how Kubernetes architecture is easily built in order to make sure that the declarative state or whatever is the state declared by the cluster is always maintained. And the kube scheduler is the one that is going to help place the applications on the respective nodes. Nodes are nothing but worker nodes. So this is the simplest example of a pod. You will never forget this. Just remember of a p pod. So here, this is a container. So the pod can have a single container, or it can have multiple containers. So we can have up to like 10 containers on a single pod. So each container can be having its own application. The application can be totally different. And the containers again can be built from the Docker images. Now, the other one which is most commonly used is replica set that we will see now. And like we have Dockerfile, which we have written using the from, copy, make, CMD, the 4 lines which we have seen, the basic things which are needed for the sample. Kubernetes has the file has to be formed as a YAML file. YAML file is something like yet another markup language or ain't another markup language. So this follows a strict constructs like this, which you see here. This is a basic one. You have something like an API version. All these YAML file samples, you will get them on kubernetes.io. So depending on your application, you can actually take the base sample and then make modifications so that it's easy for you to build on something which is already solidly tested. And then the kind you define as a pod, and this is the name of the pod what we give, and this is a label which we have. And the pod as nginx is using the image nginx. Again, image nginx, the moment we say if it is not there from Docker Hub, this image is going to get downloaded. And these are certain API versions which we use for pod. It is V1 version. So don't worry if this is not already familiar or you're hearing for the first time. For all these things, we have sample YAML files. So it's easy for us to just refer to the YAML file and copy it from there. And the next one is namespaces. So namespaces are boundaries. So you have 4 namespaces here, which are represented here like 4 houses. So which means the resources within the house 1 will be used only by the residents of house 1. So we cannot have somebody else coming in and taking the resources from here. It's called stealing. So in Kubernetes world, all the resources are perimeterized with namespaces. So within a namespace, the resources will be having access to, the members will be having access to the resources here. So namespace is a very important construct. So if you will have to have some communication across namespaces, then we'll have to follow certain service model. The other one is replica set. When you want to have, like in the previous example, we spoke about like we are going to have like 5 users log in, say by 9 a.m. and we always want to ensure that there are 5 pods which are running for these users. So at that point of time, because they're exactly same, you define the replica set as 5 and then expect the users to so at any given point on 5 is already maintained. Even if you try to make it 6, one will be terminated and still it'll become 5. If you try to delete 2 or like kill the pod or stop something on it, within few seconds it'll again come back to 5. So that's the beauty of replica set. Rather than just native pods, replica set, daemon sets, deployments are widely used. And the other one is, so this replica set itself, when we say counter 6, right? And these are your worker nodes. The placement can happen anyway. As we discussed earlier, all 6 can either come to node 1, or you can have a 2, 3, 1 kind of a distribution. And this we cannot control. Kubernetes scheduler will be deciding where to put which pod. So P is for pod representation, N is for the node. And there is another one called daemon set. If you can think of like why we need daemon set, the beautiful example or the most commonly used example is monitoring and logging. If you'll have to monitor something, you can just place the monitoring pod on each node. Just exactly 1 copy is enough. So daemon set, what it does is it brings in exactly one copy of the pod per node. If you have 100 nodes, you can have daemon set of exactly of size 100. You don't have to define the size because the size will be calculated based on the number of pods anyway. So how many ever nodes are being part of the cluster, those many pods will be placed, one per each node. And so monitoring, logging, so wherever you need just single copy of the pod is where daemon sets are extensively used. And as the masters and workers, whatever we are seeing, right? So this is how they are represented. So you will have, when you do kubectl get nodes, will list out what are the masters. Like 3 masters is a typical use case we have. That is for high availability, because if masters go, if you have a single master and the master goes down, then pretty much the cluster becomes unusable. So it's important to have 3 masters, and number of workers is totally up to the admin to decide like how many workers are required. One thing we need to know is per worker we can't exceed 110 pods, which means more than 110 pods you can't push on a single worker. So that is the reason the usual practices have like 3 to 5 workers depending upon your pod input. If you're thinking of having 5,000 pods on your application, then definitely you need to have 50 workers at the minimum. And also this so when you this kube config file is what gets created when we create a Kubernetes cluster. So this config file, you can refer it using hyphen kube config. If at all you have multiple Kubernetes clusters, it's a good practice to pass the kube config file or the kube home, which is the environment variable. It can be set. And this is using Docker 18 version, and the Kubernetes version is 1.16. So this is a Kubernetes version, what you see. So Kubernetes versions run very fast. So almost every 3 months there is one release which happens, and the upstream Kubernetes, the way it gets releases is very rapid. So it's very important as a developer. We'll have to be extremely cautious that when a new Kubernetes release is coming, we need to watch out why it is being released. Is it just a new feature payload, or are they fixing some security fixes? If it is security fixes, then immediately we'll have to patch the cluster, because otherwise we will end up losing some of our customers, or having some security issues in the applications can result into exploitation. That is not recommended. And what Kubernetes offers are like these are the few points, like 8 points, which are very, very important. The first one is service discovery and load balancing. So, as the name says, right, service discovery. So, Kubernetes has this feature which assigns the containers with their own IP address and a unique DNS name, so which can be used to balance the load on them. So like we hit google.com, right? This google.com is not just an application which is running in one machine. It is just the load balancer IP what we hit at the back end. In order to serve the google.com, or whenever you do some search on the at the back end, there are different containers that is doing the job, or some backend processes. But the unique DNS address is still google.com. We don't type in an IP address there, or we don't type in something else and then expect it to go to google.com. So that is the advantage of using this service discovery and load balancing. In the advanced topic, we have Kubernetes services also. So that is like node port, cluster IP, load balancing services, and headless services. So those we can talk about in the detailed class. This is an introduction. So we want to cover all the basics which are required for us to get started and start building some applications on our own. The second point is planning and placement. So the placement of containers, as we have seen, the scheduler is what is taking the decision in order to do. So as a user, we don't have to bother about the node on which this application is being placed. And also this decision by the scheduler is taken based on the restrictions. Like we say that I want my pod to have like say 8 GB of RAM, or maybe 4 CPUs or something. Then depending upon which node has that kind of a matching spec, the decision is taken care by the scheduler and the pods are placed. The third one and the most important one is auto scaling. So in Kubernetes, what happens is, as in how the load is being pushed, You can configure it in such a way that automatically when the load increases, the computing power of the cluster also you can increase. So we can add more compute depending upon the CPU usage. Say CPU usage, we can have a metric server which is monitoring, and then when the CPU usage exceeds the threshold is configurable, say 80%. When it exceeds, the vertical scaling of application is automatically triggered. And this you can also do it using a command line or using something called a pod scaler. It can be configured automatically, so the headache of the admin is going to be is going to really go, because most of the time what happens is, when we have Diwali sales or something, there will be a spike in the demand, so the usage is going to be increased by fourfold. But we just can't anticipate that, okay, during Diwali it's going to increase fourfold, I'll buy, keep servers, and then feed the servers power the complete year. That is absolutely like a law, waste of money and resources and power also. So that is the reason it's always better to not plan to the peak load, because peak load is very variant, and it causes loss of compute for the remaining days when there is no peak. Hence auto scaling feature is very helpful there. So automatically when the features are when the load is increasing, the backend compute power is also going to increase. The next one is self repair. So this we already talked about, and so this is a unique feature wherein if there is some problem with the container or with the application, so what the Kubernetes does, it will restart the container automatically. So whenever it detects that there is a failure, and if the worker nodes dies, the containers which are running on the worker nodes are placed onto the other nodes. Again, keeping the limit of 110 per node in mind. So automatically this is being done. So the node gets drained. All the containers which are running on the node are moved to other nodes which are healthy. And then and the new node will also be placed. So now this node is not good, right? So it will be brought down by draining it, and then it will be deleted. And in its place, we'll be having a new node. And the next point is storage orchestration. So storage orchestration, this is one feature wherein it will help us to mount network storage devices as a local file system. So why do we need it? We need it when we are using persistent volumes. So most of the data, whatever we are using for Kubernetes, we want to store that data. So it is generally, like, people think that Kubernetes is only for stateless application. That's not true. So for stateful application, you'll have to have a stateful, you want the data to be stored on some persistent volume. So that is where storage orchestration comes in very handy. You can define your own PVCs and PVs and use it in the YAML file and claim the storage. Declaratively, the user can say like, hey, I need 2 GB of storage, and then depending upon the backend compute which is connected to these servers which are hosting the Kubernetes cluster, a 2 GB of allocation quota will be given to the user for consumption. And the other one is batch execution. So Kubernetes manages both batch and CI workloads along with replacing containers which fail. So that is just first it will restart. If restart doesn't help, it will replace and it will throw away. Basically, it doesn't even try to repair it. So that is where it's called like cattle versus pet. Pet, you don't want anything to happen to your pet. You love it the most. But then when it comes to cattle, where you have like thousands of the same kind, your response would not be the same. So instead of having affinity towards repairing something, the when it comes to cattle, it's more on like replacing. And still, end of day, the application has to be healthy and should be in a serving state. The last but one is deployments and automatic rollbacks. So during the configuration changes, when the upgrade happens, right? Say for example, we are currently in 1.16.4 and 1.17 is out. We'll have to upgrade it. So Kubernetes takes care of these upgrades in a rolling upgrade fashion. So what it does is first one node goes down, and then a new node is provisioned in its place. A new node with the higher version, say 17 version, and then one by one the nodes are like brought down. So what is the advantage of this rolling upgrade is, if anything fails, it will also do a rollback. Rollback is automatic, and then because it is doing upgrade in step by step mode, like one node after the other, there's no downtime for the applications which are running. So say google.com is going from Kubernetes version 16 to 17, we would not be able to figure it out because it's happening in the rolling batch. So still the service, the API requests are still served. Last one is configuration management and secrets. So this is like the key information or the classified information, like keys and password. They are stored under under the module called secrets in Kubernetes. Let's see a demo, like how we do the lifecycle management of containers using Kubernetes. If you have any questions, please use the chat window to post the questions. Okay, so this is the YAML file again. So a YAML file is what is required for Kubernetes in order to like kubectl. This goes as an input in order to create. So when we create an application, we say kubectl create -f and then pass the YAML file. And here you are seeing the kind as deployment. So previous one we saw pod, and then this one is a deployment with the app name as nginx, and then this is the label of nginx. The image version is 1.8. Here we are specifying a version number. So if the version is not specified, then by default the latest version of the nginx, whichever is available in the repository. It can be Docker Hub, which is a public repository, or you can also configure it to any of the private registries which your organization is using. So this is the name of the deployment. We call it as nginx. And this is a replica set. And then we have defined the replicas as 1 and the image as 1.8 nginx. So let us create a application now. So upon success, this is what we see. You see that the deployment has been created. If there is any problem, most often what happens is this YAML file is very sensitive. So just like Python coding, so if there is any space error or there is any a character which is missing, it will throw an error. So you'll have to be cautious in uh, when you're writing these YAML files. Now let us get the deployments. The deployment what we had used is nginx-deployment, this second one. The one which we deployed 6 seconds ago, the second one. And then let us describe it. Describe is nothing, is similar to like having a show of what was the entity about, just to show that this is the deployment and the app we use is nginx, the image name, and what is the port on which it is running. So currently the replica set, as you know, we had given it as 1 in the YAML file. Again, so the second row here, the nginx deployment, we have 1, which is like running since 43 seconds. These are the pods. So we can also describe a pod. You can see the steps here that it has created a container and it has started also. Now we are going to change the replicas. So in the YAML file, instead of so there is one replica. Oh no, let's change the version number. Let's go back in version because somebody came and told us that nginx 1.8 has a problem, and in the organization we cannot run anything which is 1.8. So now we changed it from 1.8 to 179 and applying the YAML again. So because we have already created it, we are just going to apply. Let's see this here. So when we apply, what is happening is the pod which is running has gone into a terminating state. And then there is a new pod that has come in the after as soon as we had clicked. In 4 seconds, the new pod has come. So what do you think that 4 seconds one is? Yeah, correct. So that is the 1.7.9 version nginx has come. So this pod is going to disappear. The one that is in the terminating state is going to disappear. Yeah, it's gone. So we have only one pod here, and if we describe it, we'll see the version as 1.7.9. We'll say describe pod, name of the pod, Enter. Yeah, see this. NGINX version is 1.7.9. So it's very easy to make any changes with respect to the version of images. We don't have, there's nothing like uninstallation, there's no installation again. We don't have to clean up any of the existing files or shared libraries. Now let us expose this deployment so we can access it from our laptop. This is just like exposing any other deployment, same way. We're just using a type node port. So see, this is the port number 30680. Yeah, the second one is what we intend to do. It's in running state from 78 seconds, and this is the worker. This is running on the worker node. So we have a master and we have a worker also for the cluster. Now this gets interesting. So now we have exposed the NGINX web server by mapping to one of the IP addresses. So this is the IP address with which we will map. And if you recall, when we have exposed the deployment using using a port number, so we'll try to access that port number with this IP address on the browser, and then see if we are able to uh, access the NGINX application which we have deployed. That is what is important, right? We deploy application, but it's important that we are able to access the applications also. So we'll have to key in the port number, that is 30680. Yeah, so here it is. So we are able to get to the NGINX app using the node port service. We created a deployment, we have exposed it, and we also have seen like how when the image version has changed, how it had that actually terminated the pod which is running NGINX, brought in a new NGINX pod, and we were able to access the service. And that is what we have seen so far. We can actually log into this container also using exec and IT. What it does is it's interactive. So you can get into the shell, and then so here what we are doing is we'll make some modifications in the welcome page of NGINX. So user share NGINX HTML is the page where the welcome page is actually rendered. So whatever you see like welcome to NGINX, this is where the content is going to be. So we'll just modify the welcome to NGINX using set command in the file, and then change it and save it, so that next time when we launch the NGINX application, it should show what we have changed and not the default one. So which means the changes are being persisted. So we'll just say welcome to Kubernetes demo and then save this file. Yeah, index.html. So now we have something called welcome to Kubernetes demo. It was welcome to NGINX before, so that's what we changed. Now again, let's access the port, which is given here, 30680. Yeah, so we have welcome to Kubernetes demo. So we have seen like quite things. So from a deployment, exposing it to a service, going through the rolling upgrade process, and then modifying the changes and being able to visualize that these changes are persistent. And then for getting started for us, right, we also have a tool called Rancher, which can be used. And this is a free tool. So you can just download Rancher and then see how it manages the tool. So the advantage of Rancher is you don't have to know anything about the kubectl commands. So only thing is you just need to do is first time when the cluster is being created, the cluster has to be mapped to the Rancher, and then it'll start displaying in the UI. So this is one tool which we have, and this is free. We also have some tools which work across clouds, which I'll show it after this demo. So now Rancher is nothing but just a Docker image, so that can be pulled and then we can start it. So let's start this demo. So let us get the IP address of this machine. Yeah, this is the IP. So let us do Docker run, and then we are bringing in Rancher. This is the image. The image started running on the local machine. So let us access 10.197.37.190 190 and the IP address. First time we'll have to give the username and password. That's not saved as part of configuration or anything. So the first time it'll ask us to give a new password and confirm password, the Rancher dashboard. So once it is set, you can save it to the browser bookmark. So that again, that 190 is nothing but the IP address of the local machine. So we have created the previous cluster, right? So that cluster we can add it here. So you from Rancher, we can either create clusters if we have any of the cloud instances, or if the cluster is created native with native Kubernetes, we can just import it. We can just create some entry here and then get to the kubectl file. See here it says you'll have to get this file and then run kubectl apply. Just copy this one and then run it on the local machine. It's going to create some bunch of pods and service accounts so that Rancher will be able to access the cluster which we have built. Yeah, so this is what we have built. The nginx deployment, the one which we have used previously with 1.7.9. The previous demo and this are connected. So with the 1.7.9 nginx which we have deployed is what we are trying to add it to the Rancher. Now here we have the replica set as one here, right? The second one, it has 1/1, so which means the desired state is 1 and the actual state is 1. So for this one, now watch this. We are just clicking plus so that we have increased the replica set to 2, which means we should be having 2 pods of nginx deployment. See, you see the second one got started, 9 seconds here. So this is what has started. So we'll have 2 pods. And then again, you can go ahead and change it back to 1. And this is the log. And specifically, we can also check the events and the logs, like what has happened. This is very useful when we are debugging the application, because what happens is the pods are ephemeral. So when we lose out a pod, the logs associated with it are also gone. So that's when having these kind of a view will help us to know like what events have happened and how it has reflected on the logs and what exactly happened to debug if there is a problem. Okay, and then now let's see. Yeah, so there is another tool also called Tanzu Mission Control. So advantage of this is this can monitor across clouds and it can still provide a single pane of glass. So if you see that we have the provider as AWS and this is Azure, we have vSphere here and GKE. So all these kind of clusters, irrespective of what version they are running, will still be able to see them in a with a single view. So this tool is also very helpful in order to manage Kubernetes. And the best thing about this tool, which is not there in Rancher, is that it will help you run inspections. So inspections are nothing but we have a conformance test which we need to do. So whenever there is a new version of Kubernetes which is built, and it is absorbed into our application, we will have to run conformance so that we know the cluster is conformant, which is nothing but it abides by all the rules which are set by the community and which is accepted by open source. So for this we have like end-to-end plugins, we have networking tests. All these tests would be run on the cluster, and it has to have very good pass percentage. So the Tanzu Mission Control tool helps us to run this kind of inspections on various on clusters which are running on various clouds. So here we are seeing about different clouds that are being supported. So that is on how do we manage the whole system, how do we get to the single pane of glass. And then, yeah, so we can take questions here. We have still 5 minutes left. So please post your questions in the private chat, or you can comment in the live comments. So we'll get back to you shortly. Auto scaling is with respect to vertical scaling up only, or does it do horizontal scaling also? So this question is from Priyadarshini. So it also does horizontal scaling. So what we have two things. So one is horizontal pod autoscaler. It's called HPA. The other one is VPA. That is vertical pod autoscaler. So vertical pod autoscaler, what it does is it will keep on adding the worker nodes, more worker nodes. In horizontal pod scaling, what happens? The pods get added, more and more pods get added to the existing workers, where in the other case, the more and more nodes get added. So for this, usually the best use case is on the cloud instance, right? We don't have to keep adding nodes. Cloud has this cloud controller provider which automatically provisions these nodes. So it is easy for us to do vertical pod scaling on cloud environments. Yeah, does Kubernetes can use any ML modeling and model upgrade? So for specifically for machine learning in Kubernetes, there is there is a module called Kubeflow, Kubeflow. So that should be that can be looked at. This question is from Paritosh Gupta. So he is asking about the ML model deployment. So please try Kubeflow, which has Kubernetes, and it has got lot of machine learning and data science related algorithms embedded in that. And it can be installed using Helm chart. So we had two questions so far and we have answered them live. Oh yeah, so we have some questions here. Ah, okay. Yeah, where does the magic number 110 come from? By Sanjeev Bhagat. So this magic number comes from the Kubernetes community itself. So it is so beyond 110, if we push, what happens is the pods don't come to ready state. They will be stuck in a scheduling pending state. So they won't even get scheduled. So the pod scheduler, the Kubernetes scheduler cannot handle beyond 110. So magic number comes from Kubernetes itself. Any study material will be shared. I think, yeah, Usha answered that. Yeah, for the quiz question, I think there is somebody asking like why not option B. So the reason why it's not option B is because option B had it was being used for performance. So the moment it is performance, we expect usually performance testing or performance engineering is done on a pre-designated hardware, so that the results are accurate, because they usually do some comparative studies, right, on the similar kind of hardware is what the comparison is drawn. So that is when for performance or anything which is heavily built on hardware dependence, like CPU intensive applications or something, for that we don't recommend continuous. But you can still do it if you have the hardware available, like GPUs and all are required for computing certain kind of applications. So for that, we can still use containers. Yeah, and there is one question, I think we can take this. What happens few nodes get disconnected due to network partition? Do the nodes are auto down? Yeah, usually these nodes when they are down, right? So what happens is the master will be continuously polling for the health status of these nodes. During network isolation, the master will not be able to ping to the node, and it master will mark the node as unusable. So it is something like it is cordoned off or it is quarantined. So the new placement doesn't happen, and then because it can't drain the node which cannot be accessed. So on the new nodes, what on the existing node, what it does is it just depending upon the replica set or the daemon set rules which we have insisted, so the pods would be started on the other worker nodes. Yeah, so last question we can take it is okay, the kind field in YAML file is just like what is the type of the object you want. It you can have it like a deployment or pod. It can be service. It can be wait, I'm trying to you can have it like a service, pod, deployment. So this is just like you declare saying that this is the kind of the inventory object which I want to build, and then based on the kind is what the other parameters are defined, like labels or selectors which you can use. So we can also talk about this in the advanced topic, like how do we write our own YAML file by coining several applications and make it look like a complete end-to-end application in Kubernetes. And yeah, anytime for interactive, and if you want to learn by yourself, there is a portal called Katakoda, Katakoda. You can log into Katakoda. It will give you a mini cube kind of an instance. So you don't have to worry about installing Kubernetes or having it set up on your system or taking some DigitalOcean kind of an environment. You can use Katakoda and then still be able to understand, learn, experiment all these Kubernetes, because once we hear, we may not be able to remember forever, but if we start doing it, we can never forget it. So please use Katakoda for learning, and Kubernetes or .io also has a very good interactive shell, so it will help you learn. It will help you write the YAML file, execute the command, see what is the change that is being brought in. Katakoda is Katakoda. Somebody was asking for the spelling of Katakoda. So you can use Katakoda. It's not just for Kubernetes. It's actually for about 250 plus live sessions are there. Katacoda. That's the spelling of it. Katacoda. You have about 200 plus courses are there. So AI, ML related stuff is there. You have Kubernetes, you have Docker, containers, you have Istio. Lot of hands-on environments you get using Katakoda. It's a bit slow, but then I think it will still work when you're not doing it in a bulk classroom kind of a setup. Yeah, I think that brings us to the end of the session. Any questions you have, just keep posting here so that even if we can't answer now, we can, yeah, we can come back to you. Oh, there's one question by Chaitali. It's how to how to handle multiple deployments of containers in multiple clouds. So there we have something called Tanzo application catalog is there. So earlier this was known as Bitnami. So that provides you the deployment style based on the destination cloud. So yeah, it's a very good question because this the YAML files everything change, right, when you have it on Azure or AWS. So and we don't have to even take care of this nitty gritty. So everything is done by Tanzo application catalog. It's free. You can just log into that, and then depending upon what application you want to host on which destination cloud, we can just choose it and then copy the YAML file from there. Yeah, and another question is, can nodes join the dynamically the cluster? If the if see, it depends on how the nodes are being provisioned. In cloud instances, the nodes, the moment they join using Kube ADM, and then otherwise in the natively, if you are installing like from the grounds up, then we will have to join the nodes to the uh, master. Yeah, Chaitali, it is Tanzo application catalog. It's also known as Bitnami, Bitnami. So you can, and also it will help us deploy something on your laptop or on virtual machine or on cloud, irrespective of where the destination is. Yeah, thank you so much, and thanks for asking like a lot of questions and then coming forward to learn. Happy learning and have a great evening. Yeah, Ashish, pods will be moving to different to new nodes. New nodes, if the new node is coming, yes, the pods will be automatically moved if the resource constraint is there. If already the nodes are very happy on the already the pods are happy on the nodes, then you won't see the sudden gush of movement. Yeah, advanced session, we'll talk to the organizers and then we'll plan to have it. Thank you so much. Bye. Have a good evening and stay safe, stay healthy.